The air is crisp, temperatures are dropping, and winter is officially here. Welcome to The Explainer, my fellow Ice Cube explorers. Today, we are exploring a winter wonderland, the science of snow, ice, and style.
Have you ever looked outside at that sparkling white wonderland and wondered where all this freezing stuff actually comes from? Or, let's be real, asked yourself, why on earth do I look like a giant marshmallow the second I step outside? It's a fantastic question. In this explainer, we're going to unpack the atmospheric science behind all that winter weather and, use a little thermodynamics to figure out exactly how to optimize your winter wardrobe.
Okay, let's dive into this. Act 1, the sky and the secret of snow. Let's shift our focus way up high into those freezing clouds where the real magic actually begins.
So when we see snow falling, it's pretty easy to wonder if clouds are just, acting like giant snow cone machines secretly shaving ice over the earth. But the reality? It's way more fascinating. Snow actually starts out as tiny, totally invisible water vapor droplets floating super high up in the atmosphere. And when the air up there hits freezing, those little droplets don't just freeze into solid ice cubes. No way. They undergo this incredible process called deposition, where the vapor turns directly into intricate, tiny crystals of solid ice.
Now I want you to literally hold up 6 fingers for a second, because when it comes to the shape of those crystals, 6 is absolutely the magic number. But why 6? Well, it all comes down to molecular geometry. See, a water molecule is made of 2 hydrogen atoms and 1 oxygen atom. Because of exactly how those atoms bond together, when water crystallizes, it naturally snaps into a microscopic hexagonal lattice, meaning these freezing water drops grow unique, 6-sided branches as they tumble down through the wind. It's literally pure structural geometry in motion, just falling right out of the sky.
But here's the thing. Just because they share that underlying 6-sided foundation doesn't mean they all look the same. As these little crystals blow through different layers of cold air on their way down, those hexagonal lattices grow into totally different geometric patterns. In ultra-cold air, they might form into sharp, tiny needles. Under different conditions, they grow into flat little dinner plates, or those classic, delicate branching stars we all know and love.
And this brilliantly illustrates a famous winter truth. You've probably heard that no two twins in the snowflake family ever look the same, that they're completely one of a kind. Well, scientifically, that is absolutely true, because every single snowflake takes a slightly different, microscopic path through varying temperatures and humidity levels. Its structural growth is uniquely altered at every millisecond of its journey. It makes exact duplicates practically impossible, meaning every single crystal that lands on your jacket is a tiny, unique, frozen work of art.
All right, let's bring it back down to the slick ground. Act 2, down to earth and the science of ice. Let's talk about snow's slippery friend. Now, what's really interesting about this slide is the clear juxtaposition between our two winter elements. We've got snow, which is soft and fluffy, starting as these invisible drops floating high in the clouds. And then we have ice. Ice is hard, it's incredibly slick, and it forms when trapped liquid water, like runoff or puddles, freezes solidly in place right there on the ground. So the crucial point is this specific set of numbers, 0 degrees Celsius or 32 degrees Fahrenheit. This isn't just a chilly temperature, it's the exact freezing point, the precise thermal threshold where liquid puddles completely change phase into a solid crystalline state. Without crossing this exact threshold, winter would just be, well, a really miserable chilly rainstorm. And this temperature science matters immensely to your daily life because of a fundamental principle of physics, friction, or rather, the lack of it. When the temperature drops below 32 degrees and ice forms, a microscopic layer of liquid water can actually develop right on top of that solid ice. And that little water layer acts as a super slick lubricant. It severely reduces surface friction and basically turns a totally normal everyday sidewalk into a dangerously slick natural indoor free skating rink. So watch your step out there. Okay, so how do we avoid turning into human popsicles while we're navigating all this? That brings us to Act 3, you and your winter superhero gear. It's time to talk about dressing in layers, kind of like an onion, or maybe a cozy winter burrito. Surviving this frosty environment really comes down to the mechanical thermodynamics of your clothing. Here is your ultimate superhero gear breakdown. Step 1 is the base layer, things like long underwear. Its primary job is actually to wick moisture away from your skin so you don't lose heat through evaporation. Then step 2 is the toasty layer. A thick fleece sweater works by trapping what's called dead airspace. Your body heats that still air trapped in the fleece, turning the air itself into a powerful indoor fireplace-like insulator. Finally, step 3, the armor layer. Your winter coat, snow pants, and waterproof boots act as a windproof shield, preventing convection from blowing all that wonderfully trapped warm air away.
But wait, the system isn't fully complete without addressing your extremities, the magical accessories. See, there's a physiological reality at play here. Your fingers and toes are highly susceptible to heat loss, mostly because your body instinctively pulls warm blood into your core to protect your vital organs when it gets cold out. So, slapping on a warm beanie for your head, a long scarf for your neck, and waterproof mittens for your fingers are the final magical touches you need for your Arctic expedition. It prevents that rapid heat transfer and completely seals off the thermal gaps, ensuring absolutely zero body heat escapes.
So, what does this all mean for you? Well, now that you understand the brilliant atmospheric geometry falling from the sky and the thermodynamic science keeping you warm, it completely changes how you look at the cold, right? The next time you step outside into that freezing weather, ask yourself, are you just putting on clothes or are you actively operating a personal, multi-layered thermal climate system? Will you bundle up, catch a uniquely engineered snowflake on your mitten, and safely explore an awesome winter wonderland today? Stay warm, stay curious, and keep exploring.